Good morning, children. Welcome back to my channel. Last class we had finished the lesson inverse trigonometric functions. So today we are going to learn the third important chapter in your class 12 maths, that is chapter matrices. Okay, so we'll start with matrices. Now matrices, as the name suggests, it's a plural word. The singular word for matrices is matrix. So let us understand the definition through the example. Okay, suppose children, I am considering information of two children who wrote annual examination. Okay, suppose I have a child whose name is Amal and I have a child, say Anurag. Okay, they both appeared for final examination and their marks in respective subjects are as follows. In English, Amal got 45, Anurag got 50. In science, Amal got say 70, Anurag got 60. In subject maths, say Amal got 40, Anurag got 65. In subject say social studies, Amal got 80, Anurag got 60. Okay, now this information I can represent in the form of rows and columns. Now how do I represent here? One representation is already I have written Amal's name here, Anurag's name here, and the subjects, because it is common subjects, I have written like this and I have written the marks. Okay, so this, suppose if I enclose it in square bracket, this is called as matrix representation of scores obtained by Amal and Anurag in the subjects English, Science, Maths and Social Studies of an annual examination. So what do you see here, children? Here you can see that I have written Amal's name, Anurag's name horizontally, okay, and the name of the subjects I have written vertically, horizontally and vertically. That means Amal and Anurag's name I have written in horizontally, so that is called as rows. Okay, and the name of the subjects I have written vertically, they are called as columns. Okay, so this is one representation of the information I conveyed to you in rows and columns in this format. Now the same information I can write in another format. What do I do here? This time I am going to write all my subjects horizontally. Okay, so this is going to be English, Science, Maths, Social Science. Okay, and the name of the children I am going to write in the form of columns. Okay, now see how do I write. Amal scored 45 in English, 70 in Science, 40 in Maths, 80 in Social Studies. Anurag got 50 in English, 60 in Science, 65 in Maths and in Social Studies he scored 60. So this also, just look at it, this also represented in rows and columns. Horizontal, it is a row representation and name of the children is written in column wise. So here also you can see that, children, a given information can be represented. Okay, the given information which I conveyed to you can be represented in two different forms. Now each different forms of arrangement of marks scored in rows and columns is called as matrix. So what is a matrix, children? Matrix is a rectangular. Can you see it's a shape of a rectangle? Yes, it's a shape of a rectangle. It's a rectangular arrangement of numbers or functions. Now here I have written numbers. Instead of this you can write some trigonometric functions or any other values. Okay, so when these numbers or functions are arranged in rows and columns, so such a representation is called as a matrix, and to show that it is a matrix they are enclosed in a square bracket. Okay, so this is, again I say, a matrix is a rectangular arrangement of, here it is number, here it is scores. Okay, so when in definition I will say rectangular arrangement of numbers or functions in rows and columns enclosed by square bracket, or by, if you want you can put round bracket also, is called as a matrix. And every every member inside the square bracket. Okay, every member of your matrix is called as elements of a matrix. So these all those cores what we have got, children, they are nothing but called as elements of a matrix. Okay, they are the elements of a matrix. So the next important concept you should know of a matrix is nothing but, children, order of a matrix. What do you mean by order of a matrix? Okay, now let us understand through this example only. Okay, children. Now how many rows are there here, children? How many rows are there? Amal and Anurag, 2 rows. How many columns are there here, children? 1, 2, 3, 4. So the order of the matrix is written beneath the symbol of the matrix in small letters, where number of rows is written first, cross, or you read it as by the number of columns. How many columns are here there, children? 4. So the order of this matrix is 2 cross 4, where you have 2 rows and 4 columns. Don't forget, order of a matrix is starting with a row and followed by a column. So 2 4s are how much, children? 8, right? So how many elements are there? Check here. 1, 2, 3, 4, 5, 6, 7, 8. So if the order of the matrix is m cross n, suppose this is some small m and suppose this is some small n, then total number of elements is m into n, that is mn. Now this is read as 2 cross 4 or 2 by 4, and they are written in small letters. Okay, now the same information, just look here. Here how many rows are there? 1, English, science, maths, social studies. So I'll write here beneath in small letters 4 rows. How many columns? 2 columns. Is that clear? So the order of this matrix is 4 cross 2. Okay, so how many elements are there? 8. 1, 2, 3, 4, 5, 6, 7, 8. So a matrix can be written in this kind of formats. Is that clear? Yes. So this is called as order of a matrix. Okay. Now you can also have a matrix in which all entries are in the form of a square matrix. Square matrix, here it was rectangular. Square matrix means what, children? Here generally we used to write m cross n, right? So when your m becomes equal to n, then either this is an m cross m matrix or this will be an n cross n matrix, and it will take a shape of a square. Can you see this? Yes. So matrix is not only rectangular arrangement, it can also be square arrangement. Okay. So here what happens, here there are 2 rows and 2 columns. So number of rows, number of columns will make it a square matrix. Is that clear? Now now in the problems, children, when the values are unknown, you don't know the values of the matrix, then we have a general representation of a matrix. In order to avoid a long lengthy representation of matrix, what we do is, or when the entries are unknown, what we do is we are going to write the general representation of the elements of a matrix. Okay, general form of a matrix. Okay, so what we do is, the first thing is, you can use one of the capital letters from A to Z to name a matrix. Okay, so first thing is, we are going to name it by any one of the capital letters. Right now you know that if it is a matrix, it should be in square bracket, bracket, right? Then how I am going to write the elements. Now I will write the elements in small letters. Okay, elements should be written in small letters. So I will write here A11. What do you mean by A11? First row, first column. First row, leave some space. First row, second column. First row, third column. So on and so forth. Now suppose if I am deciding the order of the matrix as m cross n. So it will be this way, m cross n. So A1, A2, A3, so on and so forth. I will have till A1n. Why n? Because there are n columns. First column, second column, third column, nth column. Now it will be the name of the second row here, A21. Second row, second column. Second row, third column. So on and so forth. Second row, nth column. Alright. Similarly, I can have A31, A41. Similarly, the last row. What is the size of the last row? M. So AM first column, AM second column, AM third column, and the last one will be AMN. Is that clear? Now somewhere here children, I will have one ith row and jth column. I will have some I row, I will have some j column. So how will be the entry there? The entry there will be aij. Where what does in general any aij means? Your element is in ith row, because the first prefix is for row and it is in the jth column. Okay, so suppose if someone addresses me element as A56, what will happen? It is in the 5th row, 6th column. Have you understood, right? Where maximum the size of the column will be size of the row will be m and the size of the column will be n. So this is called as general representation of a m cross n matrix. Is that clear? Yes. So suppose if I am asked to write the general form of a 2 cross 3 matrix. General form of a 2 cross 3 matrix. How do I write here, children? I don't know the elements, so I will use small letters. 2 rows and 3 columns. So how will I write? A11, A12, A13. Yes, because only 3 columns. Similarly, A21, A22 and A23. It's a rectangular form, right? Because it is 2 cross 3. 2 cross 3. So 2 rows and 3 columns. Alright. Yes, now what is the order of this matrix, children? Order of the matrix is 2 cross 3. How many elements are there, children, here? There are 6 elements. Is that clear? Yes. Now moving on. The next important topic what we are going to study is, children, types of matrices. There are different types of matrices and we need to identify it while solving problems. So types of matrices. The first type of matrix is called as column matrix. Okay. Column matrix. What do you mean by column matrix? Let us see. Column matrix is a matrix which is having only one column. For example, minus, 1, 2 and 0. How many columns is there? One. Even though there are 3 columns, since it is having only one column, it is called as a column matrix. Second one is on similar lines, row matrix. So what will be row matrix definition, children? Very simple. The same thing. If I am going to write in one row, I have one row. Even though I have 3 columns, one row means it's a row matrix. Is that clear? So from this I can conclude that, children, if I have 1 cross 1, okay, if I have a matrix in which there is only one element, then it is a row matrix also and it is a column matrix also. Because if we look at horizontally one row, if you look at vertically one row, so this also automatically becomes a row and a column matrix. Okay, that can be happening, no? That can happen. Yes. Third one we are going to study is nothing but zero matrix, or it is also called as null matrix. Okay, you can guess, right? How it will be zero matrix? Zero matrix means, children, suppose if I have a 2 cross 4 matrix, all the entries will be 0. All the entries will be 0. Here, see, it is 2 cross 4, 2 rows and 4 columns. So, matrix in which all the elements, all the entries are 0 is called as a null matrix or zero matrix, and it is denoted by capital 0. No, sorry, capital O, because it is understood that O stands for number 0, right? So, it is zero matrix. Is that clear? Now the next type of matrix is square matrix. Okay, square matrix I have already told you, children. Square matrix is a matrix, right? It takes the shape of a square where number of rows and number of columns are same. Either you can write m cross m or n cross n. That means number of rows, number of columns are same. Okay, now the square matrix are divided into further 3 types. Square matrix is divided into further 3 types. First one is called as a diagonal matrix. Second one is called as a scalar matrix. And the third one is called as a identity matrix. Okay, now before this, children, one important thing you have to learn is, what do you mean by diagonal elements, right, of a matrix? So when I write diagonal elements of a matrix, definitely it has some relation with diagonal matrix. But one thing you remember, children, square matrix is divided into 3 parts. diagonal, scalar and identity. So each of the three should be a square matrix. That is the first point, should be a square matrix. Now so keep that in mind. Before that, diagonal elements. What do you mean by diagonal elements? Suppose I have a matrix. Okay, now since it is related to square matrix, I should have a square matrix. So I have 3 cross 3 square matrix and the entries are say 1, 2, 3, -4, -5, 0. You can have negative entries also, no, 6 and 5. Okay, now the diagonal entries means all AII. What do you mean by AII? AII is nothing but your general representation of your element, right? That means ith row and ith column, right? So what will happen here? Whatever value were first I is taking, the same thing will take, right? Here, what is the value of your row and column? Your row and column, right? Your row and column is taking value from 1 to 3. Right, so AII means what? A11 because maximum till 3, A22, A33. They are called as diagonal elements. Is that your? If I show it pictorially, it will be like this in the form of a diagonal. So which elements they are? A11, A11, A22, A3. That's why I told you diagonal elements are AII. Is that so? A11, A22, A33, A44, A55, A66, A77 like that till ANN. Is that clear? So the remaining elements you can see 2, 3, 0, -4, -n, -6. They are called as non-diagonal elements because they are not falling on the diagonal. So they are called as non-diagonal elements or non-diagonal entries of a square matrix because it happens only in square matrix, or this I can say diagonal entries again of a square matrix. Is that it? Is it now clear? Diagonal elements. Now we are moving to diagonal matrix, as I said. Now children, again a diagonal matrix. I am giving you in general example. Okay, so you will understand. So diagonal matrix is in general a square matrix. Okay, so how it will be? Say I am taking a 2 cross 2 matrix. Okay, say 3. 5 and write here 0 and 0. Suppose if my matrix is like this. So what is happening here children? Here what is happening here is my diagonal entries are some constant. Right, diagonal entries are taking some k1 are not constant, they are taking some different constant values, right? My diagonal entries are taking some non-zero values. Okay, I can say are some non-zero values, right? In this case, non-zero values, also you can see that the off-diagonal entries are 0. That means your AII are non-zero and your all other AIJs are 0 for I not equal to j. That means what here children? A11 is non-zero, A12 is also non-zero, but A12, right, and A21 is 0. This is A12, A21. So such a matrix is called as diagonal matrix. That means your diagonal entries are non-zero and all the non-diagonal entries are 0. Then it is called as a diagonal matrix. Now how it will appear in 3 cross 3? It will be something say like that 2, 5, 4 and remaining all the off diagonal entries will be 0. That means here you can see that all the AII are non-zero and other entries, okay, are 0. Then such a matrix is called as a diagonal matrix. Okay, so the next one we have named it as a scalar matrix. Now what is a scalar matrix? Now scalar matrix, as I told, it is again a square matrix. Okay, it's again a square matrix, but here the definition of scalar matrix says that when it is a square matrix and when the diagonal entry, suppose this is a 3 cross 3 matrix and the diagonal entries are same, that means the diagonal entries are taking same value. Can you look here? Here it is same value, then it is called as scalar matrix. So how will I write the definition? My all AII is some constant k and all other AIJ is 0 for I not equal to j. So A is equal to K means what? A11 is same, A11 is K, A11, A22, A33 is K, remaining all Aij, where I is not same as J is 0. So if you compare your diagonal and if you compare your scalar, the only difference is here is all are different values and here it is same values. So it is called as scalar matrix. So how it will look for a 2 cross 2 matrix? 2 cross 2 matrix, how it will look like, children? I'll write here. It will be some say 7 and 7 0 0. So it's a 2 cross 2 matrix. Diagonal entries are A11, A22 of diagonal entries are 0. So this is called as a scalar matrix. Is that clear? Some one important condition is restricted to diagonal, so it becomes a scalar. Now again we are going to put some restriction on scalar matrix. Then you will get something called as identity matrix. Okay, now let us see what is identity matrix. Okay, identity matrix means a matrix. Again I am taking a square matrix. Definition says, suppose I am starting with a 3 cross 3. It says that if all the diagonal entries are 1 and off diagonal entries are 0, then such a matrix is called as identity matrix. Just look at scalar definition and identity definition. You can see that here the values are same, but here you can see the values are same but they are 1. Okay, if they are other numbers than 1, then it is called as scalar matrix. If that values happens to be 1, then they are called as identity matrix. So here to my left side you can say different values, diagonal matrix, same values, scalar matrix, all values are 1. It is called as an identity matrix. So these are the different types of matrices: column matrix, row matrix, zero matrix, square matrix, which is divided into diagonal, scalar and identity matrix. Okay, now one last topic we are learning here is when are two matrices. See, where you can get one or more than two matrices, right? So when are matrices equal? So we are learning equality of matrices. Okay, so if I have two matrices, children, suppose if I write here two matrices, so one is a 2 cross 4 matrix. Okay, say I will write the entries 3 1 2 cross 4, 3 1 7 0 0 5 minus 8 and 4. I am giving another matrix, say 2 cross 3, 3 1 7 0 5 minus 8. Okay, now again I am giving you another matrix 3 1 7 0 0 5. Don't look at the entries, children. Okay, I'll just make a change here, you don't get confused. I'll write here 11, I'll write here 13. Okay, and I'll write one more here. Here how many rows? 4 rows and 2 columns. And what about here? Suppose if I write the elements like this, can you tell me which matrices are same here? Yes, matrices are same. First of all, when they have proper shape. Proper shape means same shape. Same shape means what? Same size, right? So if I compare 2 cross 4, 2 cross 3, are they of the same size? Are they equal? No. Why? Because this has 2 rows, 4 columns. This has 2 rows, 3 columns. So there and then itself equality goes. If I look at this 2 cross 4 and 4 cross 2, again you can see 2 rows, but here 4 rows. So again it's wrong. Now look at the last one, 2 cross 4, 2 cross 4. So that is true. That means they should be of the same size. That means same order, same number of rows and columns. Second thing is what? When do you say, can you say these two are equal? Yes, because elements in the positions, respective positions are same. A11 is 3, A11 is 3. Here second element is 1, 1, 7, 7, 0, 0. That means corresponding position wise also they are same. Is that clear? So same order, and what is the condition? Corresponding elements are equal. Then it is said to be, children, equal matrices. Is that clear? So we'll stop for today. So we have learned definition of matrices, representation, order of a matrix, and different types of matrices. Next time when we will come, I will teach you properties of matrices. So with it, we can solve problems on your lesson matrices. Thank you, children.